Welcome to the DIY Honda Garage channel. The DTC P16F4 indicates a low voltage issue within the starter cut relay 2 control circuit of a Honda CRV from the years 2017 to 2022. This problem can prevent the car from starting, as the starter relay is responsible for allowing electrical current to flow to the starter motor. Proper functioning of this relay is essential for ignition, and it is usually found within the vehicle's relay circuit board, typically located in the under-dash area or engine compartment fuse box. Low voltage in this circuit may be caused by wiring issues such as shorts or opens, as either condition can disrupt the flow of electricity. When servicing this issue, it's critical to ensure that connections to the powertrain control module, PCM, and the relay circuit board are secure and functioning correctly, as these components play integral roles in the vehicle's starting system. Sticking to manual troubleshooting steps is essential for accurately diagnosing and fixing the issue. The error code P16F4 points specifically to a malfunction in the starter cut relay 2 control circuit, where low voltage is recorded. This relay controls the electrical current that activates the starter motor, which makes it essential for engine ignition. If the circuit detects low voltage under the required specifications, the engine may fail to start. In the Honda CRV, the starter cut relay is typically located within the under-dash fuse/relay box, making it susceptible to issues related to the environmental conditions or physical damage. We must also take note that the PCM, or powertrain control module, oversees this relay's operation. Any disconnection or failure in this pathway may result in a no-start condition. Accurate diagnostics will involve checking connections, wiring, and the relay itself to identify where the issue lies. Several potential causes could lead to the P16F4 DTC. The first is poor connections, which can occur if the terminals associated with the starter cut relay or the PCM are corroded or loose. This electrical resistance might result in a voltage drop, hence causing the relay to underperform. Another cause could be wire shorts, which can occur if the wiring insulation is damaged, leading to unintended connection points that can alter the circuit's behavior. Additionally, open circuits where the wire is broken or disconnected could lead to a complete failure of electric current flow. Each cause needs a step-by-step check to ensure that these conditions are identified and rectified appropriately. Thus, it is crucial to systematically tackle these potential failure points to restore functionality. The symptoms associated with DTC P16F4 manifest primarily as the engine failing to start. This can be frustrating, particularly if it happens intermittently, where at times the vehicle may start and at others, it does not. This inconsistency could signal issues such as poor electrical connections or intermittent faults in the wiring. Additionally, if the diagnostic tool indicates DTC P16F4, it signals an ongoing issue that needs attention to ensure reliable vehicle operation. Without immediate rectification, symptoms can worsen, leading to more severe starting issues. As we continue through the troubleshooting steps, it's vital to document any additional observations or changes in symptom patterns to understand the issue better. The first step in troubleshooting the P16F4 DTC involves a basic engine starting check. Initially, you will attempt to start the engine. If the engine starts, proceed to the next step. However, if it fails to start, you will need to go to step 4. This diagnostic process allows us to confirm whether the starter cut relay is functioning correctly at the outset, providing a quick way to assess the broader electrical health of the starting system. If the engine does start, it suggests that the starter relay might be functioning, but we will pursue further verification to rule out any underlying issues. This methodical approach ensures that we are not overlooking any possibilities while dealing with the relay and PCM connections. In troubleshooting step 2, proceed by turning the vehicle to the off or lock mode. After maintaining this state, shift the vehicle to the on mode, ensuring all electronic systems are activated without starting the engine. The next crucial action is to clear the DTC using the Honda Diagnostic System, or HDS. Clearing the DTC helps in resetting the stored information regarding the initial error, allowing you to check for any pending or confirmed trouble codes that may appear again after clearing. Once you have cleared the DTC, utilize the HDS to check for any subsequent pending or confirmed DTCs. If DTC P16F4 appears again, it suggests that the fault has persisted, warranting further investigation into the starter cut relay and its connections. The third step involves examining the starter cut relay line for potential shorts, specifically the ST cut RLY2 CL mellage line. Begin by turning the vehicle to the off or lock mode to ensure no circuits are active. Use the HDS to jump the SCS, or Security Controller System line, and wait for more than 1 minute. After this, disconnect the PCM connector A and the relay circuit board connector. Next, you will check for continuity between designated test points. Test point 1 is on PCM connector A, pin number 34, while test point 2 is connected to body ground. If there is continuity, this signifies a short in the line requiring repair. If there's no continuity, the wiring is intact, directing the diagnostic process to further steps or possible PCM replacement. In this fourth step, you will focus on determining the possible failure area, primarily between the PCM and the relay circuit. Start by ensuring that the vehicle is in the off or lock mode. Following this, disconnect the PCM connector A and prepare to check voltage levels. With the vehicle switched to on mode, measure the voltage between test point 1, located on PCM connector A pin 34, and test point 2, designated to body ground. If battery voltage is present at this point, then the circuit is likely functional, and further information should be consulted concerning the DTC or symptoms. Should there be no battery voltage, it indicates a break in the circuit, requiring further investigation into the wiring and connecting components for failures. During the fifth step, the focus shifts to checking for open circuits in the ST cut RLY2 CL line once again. Start with the vehicle in off or lock mode and disconnect the relay circuit board connector A. Then check for continuity between test points defined as the female terminals of connector A pin 4 and PCM connector A pin 34. If continuity exists, the wiring is confirmed to be in good condition, and you should proceed to step 6. If continuity is absent, this points to an open circuit in the wiring, necessitating repairs to ensure that electricity flows correctly between the PCM and the relay circuit. Identifying and rectifying this open wire condition is crucial for restoring the functionality of the starter cut relay system. Step 6 requires inspecting the relevant fuse within the under-dash fuse relay box, specifically fuse number D20, rated at 10A. This fuse is vital to the functionality of various electrical systems, including the starter cut relay circuit. If the fuse is found to be blown, it signals a fault, indicating a short somewhere along the IG1 starter cut wire between the fuse and the relay circuit board. This situation must be addressed by repairing the short to prevent future fuse failures. After resolving any identified issues, ensure to replace the blown fuse with a new one to restore circuit integrity. Proper functioning of this fuse is essential for the reliable operation of the starter cut relay. ensuring the vehicle can start as intended. In the final troubleshooting step, verify the integrity of the IG1 starter cut line. Begin by disconnecting several connectors, including the under-dash fuse/relay box and the relay circuit board connectors. Next, establish a temporary connection between terminal A, which is a female terminal of the under-dash fuse/relay box connector, pin 23, and body ground using a jumper wire. With the setup complete and the vehicle in off or lock mode, check for continuity between test point 1, located on the relay circuit board, and test point 2 at body ground. A successful continuity test suggests that the wiring is intact, allowing you to replace the entire under-dash fuse/relay box as needed. If continuity is absent, then the wiring has fault conditions that would need to be repaired to guarantee proper function of the starter cut relay circuit. After completing the necessary repair steps for DTC P16F4, it's crucial to ensure that all repairs have effectively resolved the problem. Begin by confirming that all associated wiring and connections to the starter cut relay and the PCM have been properly addressed. Once findings validate the repairs, use the HDS to clear any remaining DTCs. Following this, it is advisable to retest the engine to confirm that it starts and the vehicle operates reliably without recurring trouble codes. Monitoring system performance over a short duration is an excellent way to validate that the repairs are indeed successful. This verification process solidifies the effectiveness of the troubleshooting steps taken, promoting longevity in vehicle performance. To avoid encountering DTC P16F4 in the future, implementing preventive maintenance can be highly beneficial. Start by conducting regular inspections of the wiring connected to the starter cut relay and PCM. Check for signs of wear, corrosion, or damage that could compromise electrical connectivity. Securing connections and maintaining proper terminal integrity will ensure consistent voltage flow and reliable operation. In addition, it's advisable to replace any components that appear worn or damaged, as even a small issue can lead to larger electrical failures. Fostering a proactive maintenance strategy helps in ensuring that the car operates optimally and increases the lifespan of critical electrical components. In summary, encountering DTC P16F4 within a Honda CRV indicates a significant low-voltage issue in the starter cut relay 2 control circuit. This guide outlines a systematic series of troubleshooting steps tailored to diagnose and resolve any underlying electrical issues. Understanding the potential causes, such as poor connections or wiring failures, is critical for an effective repair process. By following the diagnostic steps presented and implementing preventive measures, you can enhance the reliability of the starter system and reduce the likelihood of similar issues arising in the future. Remaining vigilant in both troubleshooting and maintenance leads to a dependable vehicular experience, ultimately enhancing both performance and safety. Please like and subscribe to the channel. See you next time.